Well, so David has warned us that AI will make the world incomprehensible, and now I'm going to tell you how to do it. This actually, what David has described here, I sincerely encourage all of you to consider throughout the rest of the day. I mean, really, the rest of your time here at the summit really is going to be about how to do things. Well, behind all of the projects that we take on, behind all of the goals that we pursue, are these moral and ethical questions that come from taking more observations about the universe. So many, in fact, that we actually don't know right now all the purposes to which those observations will be put. And what David has described is that now the cost of pursuing more outcomes, pursuing more possible futures, has dropped precipitously. And so in some way, it's incumbent upon us to figure out the other purposes for the data that we've already collected, to figure out the option value of these observations we've gathered together. Well, in order for that to be cost effective, there has to be some kind of technology that helps you to do that. And that is actually what I'm going to talk about here. It's very, very specific. It's very, very narrow. But it is just a little piece of connecting this larger idea about observations in the universe to, well, how do you do that? How do you practically make some use of this stuff? So we are going to change altitudes here from the very, very high global strategic perspective to something extremely specific. So I just want to warn you before you all get the bends from depressurization. All right, so we're going to talk about these things called data lakes and the way that they are changing. And just so I've got a gauge here, who in this room has worked on implementing something that you call a data lake? All right, so I'm going to call that about a third, I think is fair. Okay, so the place to begin in talking about data lakes is, in fact, with this high-level idea of data capital. All right, so we've got all of these observations about the world. Well, and we talk a lot about data. We get together and spend hours talking about data. How can there possibly be more to say? How can it be that we still get together to talk about data in new ways? It's because behind all of the talk about digital transformation and big data and AI, there is a larger economic story. And that economic story is the rise of data capital. So data is a kind of capital. Now, you've all heard the metaphors. Data is the new oil, data is the new gold, data is the new electricity. That one is particularly good. This is not a metaphor. What we are saying with data capital is data fulfills the literal economic textbook definition of capital. Capital is a produced good as opposed to a natural resource that you dig up out of the ground. But more importantly, capital is a necessary input into another good or service. It's what economists call an economic factor of production. If you don't have that factor of production, you can't make the thing you want to create. So just as an example, imagine that you want to create a dynamic pricing algorithm, and you want to do it based on past observations about what people have bought and what other customers who share certain characteristics have also purchased. Well, if you create that algorithm, but you lack the data to feed it, the observations to fuel it, you cannot create that dynamic pricing service. Just the same way that you can't make an Audi if you don't have any aluminum. Data is a kind of capital. And so this is how we define data capital. It is the recorded information necessary to produce a good or service. Now, here's the thing. It turns out that for a lot of the observations that companies capture, say out of their transaction systems, or let's say in their customer relationship management systems, a lot of those observations were captured for a single specific purpose, as David described, designed for anticipated activities and outcomes and captured for those purposes. Well, what's happening now is that companies are starting to realize there is an option value on those observations, on that data. It is possible to repurpose those observations for something else. The challenge with that is how you reduce the time, the cost, the effort of getting the data you want into the shape you need. If you capture data for a specific purpose, then you build a model for it. And not metaphorically, literally, as David described. You build a model in the database, and then you fill that model with conforming data. Well, you can only answer so many questions in a in a price for performance kind of way on that database. So what if you want to use that data for some other kind of analysis? What do you do? This is where data lakes come into play. So for those of you who are not familiar with data lakes are a convenient way and cost-effective way to store a lot of data with completely diverse structures so that you don't have to build the model ahead of time. You just pour in extracts out of other databases, you pour in XML, you pour in JSON documents, you pour in documents, just regular long-form documents, whatever you got. And that's great. This storage mechanism holds all this great diversity of data. And then you put on top some set of tools that allow you to maybe transform it, change its shape, and do some analysis on it. That's the basic purpose of a data lake. Its job is often to support data science teams, and its purpose is to reduce the time, the cost, the effort to repurpose all of these different observations into other analyses. Well, there's something interesting going on in this world of data lakes. One is that they've become mainstream. Most of the companies that we talk to at Oracle, they've already got some kind of way of doing this. And it's a system that lives parallel to their relational databases that have specific models that were built for specific purposes. The data lake is a thing that lives alongside. So here's what's happening here, is that data lakes are growing, but one of the core technologies that was so important from the very beginning in data lakes, Hadoop, is shrinking. So we've got some, this latest survey data from 2018 is just released, and we have copies of the report here. But here's what we've seen from 2016 to 2018. When we asked, and this is roughly 200 IT professionals, do you have a data lake of some kind? In 2016, 20% said yes. And these are IT professionals working at corporations. And then in 2018, 37% said yes. So the adoption of these data lakes is growing. Well, then we asked, do you have a Hadoop installation? Again, Hadoop was kind of the major way to store diverse data and then do some analysis on top of it, was the mainstay of data lakes. Well, in 2016, when we asked this question, 55% of these IT professionals said, yes, I do. And then in 2018, 2 years later, only 44% do. Well, that's a little odd. Main idea is gaining adoption. Core technology to do it from the beginning is falling in adoption. So what is going on here? Well, what's happening here is that these data lakes are being implemented in a new way. There is a new shape of data lakes. And here are the big factors driving this. So the big factors driving the changing shape of data lakes are cloud, object store, and Spark. So let's just quickly talk about each one of these. Cloud, I'm going to take a wild risk and assume that I do not have to explain to anyone in this room what cloud is. Cloud, using somebody else's computer for whatever programming and storage and you want, this is what's happening here. What we see today is still on-premise deployments of Hadoop are dominant. So when we ask these IT professionals, this is from the latest survey, where is your Hadoop cluster deployed today? 39% said cloud, 62% said on-premise. The numbers don't exactly add up to 100 due to rounding in this case. But this is a snapshot. The trend is going to cloud. Using somebody else's elastic, infinite, globally available computer is just a deal that you can't turn down. So this is just a snapshot in time, but what we hear anecdotally is that our customers are all saying, we've got this data lake set up, and it's just a pain in the butt to keep it happy and keep it performant, and plus we don't really gain any competitive advantage from doing this because all of our rivals have one too. So we would just like to put this in your computer out in the cloud and have you handle it for us. So that is the first factor changing the shape of data lakes. The second one is object store. Now here's what happens when you go to someone's cloud. Could be Oracle's, could be AWS, could be Azure. When you go to somebody's cloud and start putting your data in it, start doing your analysis in it, we will all tell you, you can deploy Hadoop on the cloud if you want to, and we'll manage it for you. You could also put it in an object store, which is even cheaper and easier to run, and you're going to have easier access to it. And a greater variety of tools are going to be happy with it. So for those of you who are not familiar with an object store, this actually is a really old technology, decades old, much older than Hadoop. But it basically fulfills this same need. Some really cost-effective, highly scalable way to hold a whole bunch of diverse data where you don't have to build the model first. Just a great big bucket that you pour data into of any sort. That is what an object store does. So as companies move their data lakes to the cloud, they're preferring to use object store as the storage layer instead of Hadoop. So here's what we found from these folks. 24% have got an object store deployed, 15% are considering, and of those object stores that exist, the ones that are deployed in the cloud, that's 21%. Now again, this is a snapshot. And the trend that we see on this adoption is that corporations are increasingly interested in deploying their data lakes in object stores on the cloud because it is so much simpler to do than to do it with Hadoop. So that's the second factor in the new shape of data lakes. And the third one is Spark. Now Spark, if you're not familiar with that, Spark is an in-memory framework, a distributed framework for analyzing data in memory. Basically, it pulls one of the key tricks in cloud open source software, which is massive parallelism. Just spread the work out over a great number of computers instead of having to have one great, really powerful one. And it also does this other trick that is increasingly common in the world of analytics, which is to do everything in memory. Because when your data is sitting in memory instead of down on the disk, everything goes faster because you don't have to make trips through the machine down to the disk, which is much slower than just pointing at the data or just calling the data out of memory and bringing it to the CPU. So Spark is an in-memory, parallelized open source analytics framework. And it has, among our customers, it has supplanted MapReduce, which was kind of the workhorse at the top half of Hadoop. If you've got data science teams at your company, you can go and ask them, what's your feeling on Spark versus MapReduce, and they will spit on the floor and then tell you how awful MapReduce is and how great Spark is. The difference may not, this is sort of not only the opinion, but also we see the actual usage of this technology matching that opinion. So we asked these IT professionals again, how many of you have some kind of deployment with Spark? 26%. Considering it, 15%. And of these deployments, what percentage are in the cloud? 31% said ours is in the cloud as opposed to on-premise. These numbers are very, very similar to the object store numbers. So overall, what we see happening here is that the way that companies are what they're looking to deploy as they try to create an environment where they can more easily repurpose data, diverse data, for new uses is in the cloud, stored in object store, put Spark on top for analysis. Well, what are they doing with it? They're destroying the world with machine learning AI. That's what they're doing. So this is one of the reasons why it's so important to keep these ethical considerations in mind, because the economic incentives of creating machines that can reason about the world more effectively than we can, even if we can't understand how they're doing it, are powerful. So corporations are, again, you see the same kind of numbers. When we ask them about machine learning, 25% say that they've got some kind of machine learning environment deployed, and that just means that they're using one of these frameworks like TensorFlow or Keras or something like that to build neural networks, or to do some kind of unsupervised learning on classifiers or something like that, or recommendation engines in a call center app, or for recommendations on an e-commerce site or something like that. 20% are considering it. Of those deployed, 33% in the cloud. Remember, all these are snapshots. What we hear anecdotally is just the move is to the cloud, and the simplicity that provides in making it easier to repurpose data, including getting it into the shape you need for some new machine learning model. So at the end of all of this, the thing that I would actually ask you to remember is the data lakes, the way they're being deployed is changing. Cloud, object store, Spark. But really, the thing to remember is that data is a kind of capital. It is not merely a record of what happened. It is an economic factor of production in new digital goods and services. And so that means that you are competing for data. It also means that you are competing to create new ways to use data that are unique to you, and hopefully are on the right side of history when it comes to the ethical and moral questions of using data to better understand the world and operate in it. Thanks very much.